First and foremost, I expect people who are sincerely trying to learn and figure this out are invested in learning about computers and computer programming. But then, without further ado, let's get to the bottom of it. So you're working on some programming project, and it looks good so far. Compiles, which means it is good. / to execute the file, and immediately, after a short time, the executable has a big confusion. The new terminal has the smug message, Segmentation Fault, core dumped. Well, that means nothing. So, if you're getting this message, I already know a few things about your code. You're using either C or C++, and you're either accessing the value of a previously assigned pointer, dynamically asking for computer storage from the software's operating system through malloc, or both. Now, checking your code at these places is usually a fast and easy fix. Often you can just check if your pointer is initialized by checking if it's null. If you're using libraries, null pointers can often be passed around between functions, and so this is a common source of pain.
You see, this is why we can't have nice things, Barry!
The problems might be fixed, but what's with the name, Segmentation Fault? Well, the problem is with trying to access the virtual computer memory that isn't yours, and that virtual computer memory may or may not even exist. Let's unpack that. So, obviously your computer has dynamic random access memory. Open up Task Manager, click on More Details, and there on the fourth column, percentage of the total computer memory, which varies from computer to computer. Click on the Performance tab for a buffered line graph of the various physical resources which are being virtualized and shared by every single application and background process. Click on Memory for a better look at the Windows operating system's distribution of the dynamic random access memory. The Windows OS says only a fourth of the physical computer memory is in use. Why isn't all of it in use? And what are the paged pool and non-paged pool doing? Of course, computer memory isn't strictly accessible in software. You can and should open up your computer or laptop and play with your stick of RAM. The sticks are green, blue, or black printed circuit board with gold-plated pins. They also have these black chips stuck to them. These are silicon circuits, and they contain hundreds of thousands of capacitors and transistors for storing the bits. If you have spare DRAM, you can rip off one of these black chips and tell us what's on the other side in the comments. DRAM nowadays is sold in the ones of gigabytes and is based on their speed. DDR1, 2, 3, 4, 5, 6. Bigger the number, the faster charges can be stored in capacitors or sensed from capacitors, and that exactly means bits can be stored and retrieved faster. Most people will say that 4 gigabytes of RAM is the absolute minimum. Most computers I use have 16 gigabytes. And there's a misattributed quote to Bill Gates that 640 kilobytes ought to be enough for anybody. Segmentation fault. We're almost there. You're a programmer. Programmers are encouraged to think about memory as a long, contiguous table. This table is kind of nutty. We want to give this table a number. I'm going to call this number address. We give the table a number called address, and it gives us 8 bits back. 2 to the power of 32 equals 4 billion-ish, which we'll call 4 billion, which is 4 times 10 to the 9. Anything with the times 10 to the 9 in SI units may be given the suffix giga. So if we count in binary using 32 bits, we can count up to a little over 4 billion, which is 4 giga. Now, I'm going to use those 32 bits to be the addresses. And for each address, we get 8 bits back from the table. So, this process goes number address into the table, 8 bits back. Total number of bits we can access is 4 gigabits. We've just made a stick of RAM into a table. As a programmer, we can use this table.
A new level of abstraction.
This is a great way to think about memory, but it really falls apart realistically for 3 reasons. 1. How the fuck are programs / processes, applications going to be written so that programmers don't have to keep track of the thousands of other things going on? And I do mean thousands. 2. How are programs going to make sure their memory isn't being tampered with by other programs, processes, or applications running on the same machine? Many of us have used Cheat Engine to mess around with the values stored in RAM. We've used it for Dark Souls. And 3. What is the expectation for things when we run out of free addresses? Does the computer just blue screen immediately? Or does it just use the computer storage, the hard disk drives, like random access memory? These big problems are difficult, and I had a really hard time grappling with them. But I encourage you to. I really do encourage you to pause and ponder. And I promise, if you came here to understand what does segmentation fault mean, then you're asking the right question. Because we don't suffer from those problems on our ubiquitous Dell Latitudes, HP Omens, or Lenovo ThinkPads. The solution is really incredible and boggles my mind. It is simple and gives us programmers all the security our programs desire while being easy on the mind's eye. It even acts like you're using more memory than you have. Like, is this even allowed?
What? Is this allowed?